do you know about Demetrius?
Did you know that he was the first to speak of comet of atoms?
Yes, his theories are quite a bit difficult to detach from his mentor, Leucippus. The odd thing is that the theories both had quite different intentions. While Demetrius thought the atoms were simple balls of matter with no electrons, no protons, no neutrons, he didn't develop his theory. His mentor did in 465 BC. Instead, he just expanded on it and changed it.
Well, what was Leucippus' theory?
He believed there were two different elements. He called these full, or the solid, and the second was called empty, or the void. Not much else is known about his theories. We hardly know anything about his life, taking a stab in the dark on when and where he was born and all.
I wonder why that is. But anyways, I want to know about Leucippus. What about Democritus? What was his theories?
Well, his theory can be broken up into 5 parts. The first part is that all matter consists of invisible particles called atoms. He believed that atoms are indestructible, but solid and invisible. They're homogeneous. They differ in size, shape, mass, position, and arrangement. So, for example, solids are made of small pointy atoms, liquids are made of large round atoms, oils are made of very fine small atoms that can easily slip past each other.
I wonder about his upbringing and what got him to think of his theories.
Not much is known about him, though he was from a noble family in Xerxes. He was born in 460 BCE in Abdera, Thrace, which was located in Greece, of course. His mentor was the one who made him first think about these theories.
I see, but why was he important?
Well, not only did he develop a theory of the atom that we can still use today, this caused other scientists to look at the atoms, how they work, everything that came from this one point, and without him, we may not even know about the atom today.
Wow. You know, I find it funny that he thought that atoms were just simple balls of matter. I wonder what brought him to that decision.
Everything has to be made out of something. So at some point, you get to the smallest structure possible. It would make sense that these pieces would be spherical in nature. So we're all made out of balls.
James Dalton was a man born in the late 18th century who died in the mid-19th century. His life consisted of researching atomic theories, some of which are still used today. Yes?
What theories did he discover?
Well, I was getting to that. Dalton thought that all atoms were exactly the same. All matter is made of atoms. Atoms cannot be divided. Atoms cannot be created or destroyed. Atoms of different elements differ in mass and volume. There are other parts, but they aren't the main 4, and they won't be covered on the test. So you're not responsible for learning them. So, can anyone tell me which of these theories were wrong? Yes?
Dalton's theories that atoms were inseparable and his theories that all atoms are the same elements are wrong. We know that you can separate atoms for energy and weapons alike. We also know that atoms differ in weight due to neutrons.
Very good. So, do you know what he thought a compound and the elements were? Okay, so Dalton thought that compounds were made of several elements mixed together. He thought these could be broken apart by chemical means, and as you already learned, this was correct. However, he thought that elements could not be broken down by chemical means, that this was the smallest unit you could get without looking at each independent atom. Was this correct?
Wait, so did his model look like...
At this time, the model was still wrong.
I want you to tell me everything you know about the first day of the first month of 1897.
Well, I could tell you about a man whose name may or may not be JJ. You know, JJ Thompson. And he discovered something about atoms.
Yes, go on.
Well, this man, who was probably born on the 18th of December, 1856, discovered something about him. Plum pudding model. It's an atomic model. Sounds crazy to me.
Just how crazy?
Well, it just looked like a whole bunch of protons and electrons floating around in a soup.
What else do you know?
Well, all I know is that he died inside of 1940, and he was knighted. I swear.
So why was this theory called the plum soup theory? Well, the answer is quite simple. If you take a look at this model, it literally looks like plum pudding. See? It's just a sphere with electrons floating in the middle. The electrons are like the plum and the rest of the atom is like the pudding. If you didn't notice, we're talking about a new particle, the electron. Thomson is the one who discovered this. It has a negative charge, obviously. This led him to believe there's another part of the atom, but he wasn't completely sure.
Rutherford played a very important role in the atom. On March 7, 1911, he submitted a paper to the Manchester Literary and Philosophical Society. This paper talked about his theory.
What was his theory?
Well, in his paper, he conducted the experiment with two other scientists who concluded his theory was correct. They studied deflecting angles of alpha particles that they shot through a very thin layer of gold.
What are alpha particles? I haven't heard of them.
Alpha particles are just helium atoms that no longer have their electrons. Anyways, let me finish.
Sorry.
This experiment differed from what he was actually doing, studying alpha particles. He actually found out that while the nucleus contains virtually all the mass of an atom, it only takes up 1/billionth of the volume of it, which is a very small amount. Smaller particles, called electrons, orbit the nucleus at a distance. He called his theory fly in the cathedral. We now call it a planetary model. Can you guess why?
The electrons are orbiting the nucleus, just like the planets orbit the sun.
Exactly. He also observed that there might be a particle with no charge at all, but that will be tomorrow's lesson.
Oh God. I hope we don't have to work.
So Chadwick discovered neutrons, but how exactly does one discover a separate atomic particle with no charge? And how exactly does one get people to believe him about this atomic particle? Chadwick had decided to go to Rutherford's assumption and started his own experiments in 1932 with Rutherford's help. Chadwick actually became the assistant director of the lab. Sorry, I'm veering off topic. Anyways, Chadwick's work was focused on radioactivity. It was a new concept that Rutherford had discovered in the proton. But many scientists believe there seemed to be another subatomic particle in the nucleus. Now, just how would you find it? So, he noticed experiments in Europe, mostly those of Frederick and Irene. They used a different method. He repeated their experiments, but searched for a neutral particle, one that had the same mass, but with no charge.
What was his experiment?
Well, he used alpha particles on beryllium. This made radial, which is raised from one central location. He used the radial on hydrogen and nitrogen. This produced hydrogen nuclear and not nitrogen nuclear. That's the atomic nucleus of the particles. This made him realize that the radial was not an alpha radial. This meant it had to be a neutral particle. Okay, class, your project is due. Yeah, step up with your information on board.
Well, board used the hydrogen element since that was the easiest. His atoms have protons and neutrons at the nucleus, and electrons orbit in different levels. The electron position in the orbit. The protons and neutrons are in the middle.
Very good. David and Matt, your presentation on the current version of the atom.
Okay, so the current model is called the atomic orbital model. And let's use hydrogen again for an example to keep this simple. So for hydrogen, there is one electron that goes around in kind of pattern that goes a little bit like that. And I can't really show everything with hydrogen, which has one electron, maybe right here. So let's go with helium, that has two electrons here. Now, one electron stays like that, and like goes this way around the atom, while the other one is going to end up going the opposite way. So it'll end up actually crossing over twice inside of orbit. So first you must know the energy levels, S, P, D, and F.
So S is the first 2 rows, P the last 6, and D is the 10 in the middle. F are generally the man-made ones. They're at the bottom. Let's say you were trying to find lithium, for example. Lithium would be 1s2 and a 2s1, because it doesn't completely fill up the second level. Once you're trying to get to D, it always has one less level than the one it's on. So if you are on level 4, D is level 3. With the noble gas configuration, you can do the closest noble gas and keep reading from there. Orbital notation is quite easy. You drag the orbits.
So who will help discover this version? Heisenberg, Bohr, Schrödinger, Pauling, Michelin, and others. Most of these had been in the atomic field already. Heisenberg discovered uncertainty relation, or realized this implies uncertainty in wave frequency and wavelength. Others noted that electrons could not have an exact location.
This led to the discovery that electrons could not have an exact location and only an approximation.